So, hi everyone. I'm Michael Staib. I'm a GraphQL TSC, so working on the GraphQL Technical Steering Committee. And I'm also the author of the hot chocolate GraphQL library in .NET. And today I want to talk about distributed GraphQL. Before we get started, if you have any questions during the talk, you can post it to Slido because it's much better for me to answer them after that, because if you try to scream down here, it will be difficult to ask questions. So if you have questions, just put them on Slido, and I will look them up and answer them as we go forward. Okay. Okay, let's talk about distributed GraphQL. Or let's talk about GraphQL, because I know a lot of people still don't have an idea about GraphQL. And in this talk, we start at the very bottom and then go into the most complex topic around GraphQL, which is distributed graphs. Why should you care about GraphQL? There is a recent report by Gartner which expects GraphQL's share to growth in companies from 10%, so 10% of the enterprises using GraphQL in 2021, to 50% of enterprises in the world using GraphQL by 2025, which is not far off. So GraphQL is growing hugely, and it's becoming more and more important to know about. So let's try to look at why GraphQL was invented, why Facebook actually created GraphQL. So back in the days, around 2012, Facebook created something new called GraphQL. But they only did that because they faced actually a real problem. They didn't just go out there and say, we need a new API standard or whatever. They actually had, before 2012, a lot of problems with their mobile applications. And back in the day, people thought that Facebook would not survive the mobile age. Like today, there are a lot of doubters around their strategy about the metaverse. Back then, people doubted their ability to adapt to the cloud-first and mobile-first age. So actually, the Facebook application, the mobile application didn't look like that. It was more like this, small and ugly. And the newsfeed actually was looking like this. And people were complaining about the mobile application because it had three major problems back then. Like, people were complaining that the app start was very slow, that it used a ton of data, and on top of that, that the battery quickly was drained by the application. A common thing you would do back then was just to shut down the background service of Facebook and make sure it doesn't start on the iPhone, but that was not a solution. So 3 engineers actually at Facebook started looking into this problem and looking why that is a problem to why they have this problem with the application. So what they discovered is actually that they took the technologies that they built on for their web application and put that into the mobile application. So they bet on HTML5, but they also bet on something called REST, and that is basically what Facebook was built with. So the main issue here was when they looked at the request graphs and debugged the application, they could see when it starts up, it basically would do a couple of calls, a couple hundred of calls actually. The first one was maybe like fetching the current user. And when they did that call, they could see that the application actually just needed 3 information from that request, but this call would like draw in 50 properties. So 50 properties of data, but they only needed 3. And from these 3 properties, one was actually an ID that they needed just to feed into the next request to fetch the newsfeed. And again, when they looked at this request, they could see that they actually also just needed a couple of these properties. So they didn't need all the properties that the web application that was designed for desktop usage needed. They just needed a couple of information because the screen size was much smaller. And from these 4 properties that they needed from this request, 2 were actually IDs, because they needed these IDs to feed them into the next request. So you can see where this is going. They were fetching data just to fetch more data. And on top of that, they needed to throw away a lot of the data they fetched. The data fetching graph maybe looked something like this. We call that a data waterfall, where each request depends actually on a previous request. And that means we cannot parallelize this. What they discovered there was that different clients have really very different needs. And Facebook actually was not alone at like figuring out this problem. There were patterns around this, like the BFF pattern, and that doesn't mean best friend forever. It actually means backend for front end, right? And with that pattern, you would build a specific backend for every front end you would build. And that is super awesome, because now we have a specific backend for the specific needs that we have in specific device types. And that is super easy to consume for our front-end devs. But it also has like the downsides of a lot of code duplication. So we have a lot of maintenance that we need to do, because when we change something behind our BFF in the actual infrastructure of our system, we kind of need to update that in our microservices maybe, but also in all the BFFs that use this specific microservice or even REST service that you have behind your BFFs. So we have a lot of maintenance that we have to do here, and this doesn't really scale for companies like Facebook. Another company that actually looked at issues in this case was Netflix, because they had an even worse problem, because they had much more device types that they had to support, like TV boxes, like consoles, mobile phones, and what have you. So they had the same problem, and this problem is actually that they aggregated data on the client side. So what they came up with was a similar concept to GraphQL, a bit different, and they called it the client adapter framework. The client adapter framework would introduce a client adapter code layer into the backend, and then depending on which device type or client framework would call the backend, they would select a certain adapter and then fetch and aggregate that on the backend. But this kind of broke the layering, and the client developers always had to write these adapters. They had to be injected in the backend, and that was a nightmare when you think about deployment and maintenance and stuff like that. So this was actually where GraphQL came in. And once Facebook introduced GraphQL, all these companies that were actually trying to figure this problem out rallied behind GraphQL. So let's talk about GraphQL. In GraphQL, we changed the paradigm how data is being fetched. So essentially, we changed the responsibility. So it's not the backend engineer that says what data you can fetch for a request. It's actually the front-end engineer that tells the backend what data is needed. In this request, for instance, this is similar to the first request I showed you in REST. We are essentially fetching from the currently signed-in user me the name of that user, just the name. And if we send that to our GraphQL server, we get back exactly what we asked for. It almost looks like the GraphQL server filled up the request graphs with some data. It's not like that, we will see that in a bit, but it's a good mental picture to start thinking about that problem. So as our components change, our data needs change, our device types change, we can ask for more or less data. In this instance, maybe we want also to have the profile picture and then some information around this profile picture. And we can send that again to our GraphQL server, same endpoint, and get this data we asked for. Not more, not less. But when we look at that, we can also see that GraphQL is not about flat data structures. It's actually about trees of data. And this is great with relations. Like you can drill into related objects, like the friends maybe of that user or the news of that user. So I could now suddenly ask for all the data I needed in my mobile application. Let's actually have a look at some application here. That is a demo application we often use in workshops. Let me refresh that. Like you can see, this whole dashboard that I have here is a single data call to my backend. And no matter what I'm doing in this application, you can see I'm asking here for another coin. It's just one more data call to my backend. It's never more. And if I, for instance, need some more aggregated data here, it's one more request to the backend. And we are only fetching always the data that we need additionally. Let me go back here to the front page, refresh that, and then let's have maybe a look at this request here. No, that was wrong. Okay, so this is actually the GraphQL request the backend did, and what I can see here is that I have a lot more constructs. We have something called a fragment here, and it looks much more complex than the request I did earlier in my presentation. So let's have a look at that, how this works actually. So in GraphQL, we have a construct called a fragment, and a fragment is essentially the data contract for my UI component. So GraphQL has constructs specifically made for front-end engineers. And this is, for instance, a React component of the same application. And you can see that up here I have a fragment. That is the data contract, the data needed for this component to fetch data, or to display data. Down here, I'm using this very same data. In this case, it's just an ID that I'm using down here in my component. So what GraphQL clients do basically is, as I compose my component, I'm really composing a request. So I'm using my fragment here that I'm using is basically a primitive for composition. And this is super awesome because it allows me to have this very efficient data fetching where I only fetch the data I need for a certain screen. So GraphQL gives me this unified API for all my clients that I ever have to build. And I only get what I need. So I get the power as a front-end engineer to ask for the data I need and nothing more. And this is why GraphQL actually, for front-end developers, sells itself. You show that to a front-end developers and they basically start to shake because it's so awesome to them. So what is GraphQL? GraphQL is an API technology, a query language, and a runtime to fulfill these queries. There's only one endpoint in a GraphQL setup. And to this one endpoint, I can issue any request. I can fetch all the data I need in one request. And there's no over or under fetching. So overfetching is when I need to consume more data than I want to, because the backend engineer decided this is the data that you have to have. And underfetching is every time I had one of these IDs that refer to another resource in REST, that's underfetching because I don't want that ID. I want the data behind that ID. GraphQL is built on a strong type system that has more type constructs than C#. And that makes GraphQL super predictable to use. On top of that, GraphQL is real-time. So there are three operations to GraphQL. There are read operations, write operations, and we have events, which we call subscriptions in GraphQL. And if you align them to REST operations, like the query is the GET. side effect-free reads to my system. Mutation is the put, post, patch, delete, everything that we want to change in your system. And subscriptions you don't have in REST. You could have something like SignalR, but in GraphQL it's built in. Let's have a look at a simple GraphQL example. And I have prepared here, this is an empty project so far. And let's build maybe a simple hello world. And then we dive in deeper. So I'm creating here just a new web application. That's a .NET web application. And it's basically a hello world for the minimal API. And to make that a GraphQL server, it's just one package that I need more. So in this case, I can just go here, say .NET add package hotchocolate.asp.NET Core. That's our GraphQL server. I add that. Should have prefetched that. Okay, let's reload that. And now I can build my GraphQL server. So I said there are these operation types in the beginning, and these operation types is what we need to build first. So in our case, we're going to create here a query operation type. Let me see that I have a template for that. And that's basically a class. So the root operation query is basically a class in .NET. And to resolve something in our GraphQL server, we need to introduce something called a resolver, which is a method. In my case, I want to just introduce a hello world method here. So this method is called hello. It has an argument name, which has a default world, and just it returns here a string that I built up. So this is actually all I need for my GraphQL server. I can configure it now with my DI. So I'm going up here to the builder, services, add GraphQL server. And then I say add query type. And then I'm just referring to this query class down there. Okay. But there's one more thing we have to do, and that is specify the transport. And I can basically go down here to the app part and just say map GraphQL. And then I'm done. That's my GraphQL server. I can now run it. Let's do that quickly. And I forgot the semicolon. It's always this. Another one. Ah, yeah. I see it. Let's do it. Okay, so let's call that thing GraphQL. So I'm greeted here by Banana Cake Pop. That's our GraphQL server. So we have a lot of funny names, like the server is hot chocolate, the client strawberry shake, and the GraphQL ID is called Banana Cake Pop. I can create a new tab here, and then I could write GraphQL queries. But I also could look at my schema here, and you can see I have a query type that has a field hello, which returns a string. And you can see down here, it even inferred the argument that I have plus the default value. So it's basically a one-to-one translation from what we have in C# to what we have now over the wire for the API. And that's empowering because I can infer my business layer and expose it in a much richer way to my front-end engineers. In order to query that, I can just go in here. And you can see it's powered with IntelliSense because I have a strong schema. And then I can, for instance, say just hello. Let's just have something proper here. Hello, Michael. And then that works. OK. Let's put that away. Go back to the slides. OK, so what we did here is basically we took a simple C# type. We inferred from that the GraphQL type. As I said, this method here is called a resolver in a GraphQL context. What we call this approach is actually the annotation-based approach, where we infer like our runtime language, C#, into GraphQL. That's actually what Facebook did for the first GraphQL server. From a GraphQL type here, the type is similar to the class. We call that object type. It has a field here. A field is like a method in C#. And the field can have arguments. Arguments can have defaults. They can even have more complex defaults than C#, like we could have object structures here or list or whatever. And we also have here this bang operator. So in GraphQL, the nullability is reversed. So in C#, this thing basically calls shut up, means shut up. So I know what I do. In GraphQL, it means it's non-null. And in C# we have that reversed, so we mark types that are nullable. In GraphQL, I mark types that are non-nullable. So GraphQL gives us a chance to model an interface to our core domain and expose that to our front-end engineers. Or as I said, expose our business layer in a much richer way to our front-end engineers. But GraphQL is also a monolith. And as I said, this talk is about distributed GraphQL. So let's talk about that. Let's first have a look at the monolith. Like a typical GraphQL server, also how Facebook did it, was really a monolith from bottom to top. Let me show you one here. So this is basically the back end to the front end I showed you earlier. And let me just restore that. Yes. Okay. Okay, so this is basically also a GraphQL server. It has more to it. You can see here's the configuration of the GraphQL server. We have here the transport mapping. And then we have a ton of types here. You can see like the account data that we have here for the user with all its data. We have assets, and we also have notifications. That is a big monolith. If we look at that, then we have here the assets queries. And in there, we could use entity framework like I did here, or it could be your business layer. That's actually the proper way that you have like a service layer in between that holds a business logic and stuff like that. But it's basically like one big service, right? And actually, that's good to start. Like, if you are just one team, or if you don't have the need, having a monolith is actually super good because it's simple to build. It is easy to debug, and it's also easy to update. If you think about updating packages, you just do that in your solution and everything is fine. And you could also have it distributed kind of in assemblies where you have for each of your boundaries one assembly, and that is actually good to go. Because the main thing I would consider in the beginning before going into distributed GraphQL is if folders might be enough. Like sometimes we just want to have these nice boxes, but sometimes these nice boxes are actually folders. So think about if you really need distributed GraphQL. Where a monolith becomes a problem is when we think about scale. There are a lot of other things, like it's faster to update, but it's also slower to update. If you think about you want to just change this little thing in this component, but now you have to update all the other parts because they're using maybe the same helper, or you need a new package for this part, and now you have to update all the other things. This means also that it's more difficult to adapt to new technologies. So a monolith gives you a lot less flexibility. It's easier to debug and manage, but lot less flexibility. But the main point that I hear is actually it's difficult to scale. And that is basically the opposite side that Facebook took to what was fashionable at this time. And fashionable at the time were microservices. So if you think about Facebook and their scale, you would think that they would use something like a microservice concept, but they didn't. Because for them, like the unified API, the single thing, was much more productive in iteration speed between front-end and back-end engineers. So let's talk about microservices. So the premise that people tell you is that they are easy to scale. So we can scale these things independently. That means we only scale the parts that maybe are under pressure, right? We get all this flexibility of technology. all our teams can use different technology. Like one team can use JavaScript, the other .NET, the other Java, maybe someone uses Go, whatever. Maybe you have 130 teams like Netflix and then 130 different technologies, right? Then we can work independently as a team on each of our microservices, and on top of that, they are much more resilient. At least that is what the advert tells you. And they're also easier to maintain. That's sometimes controversial, but that is the advertising. But there are a lot of cons that you have to think about before going head-on into a microservice setup. It actually has a lot of increased complexity because now you have all these different parts. How you debug that? How do you figure out issues? You have to think about network latency, about data consistency. That is also a pro of a microservice setup, that you have overlapping data because you can use that. But it's also a ton more complexity that you introduce to your system. Deployment becomes more complex, and also it is much more difficult to consume. And that's where GraphQL actually shines, with its single API for the consumer. Before going into distributing a graph, you should really think about the concerns of separation. Why do I want to separate, and what is a good reason to separate? Like the most common reason I hear is the business logic boundaries or verticals that people have. And that's basically the reason to create folders or assemblies. Because it's actually not a good reason to just create services, and that's not really microservices, like domain services for each of your business concerns, like assets, accounts, or whatever. And it's also not a good idea to have all your microservices distributed around hundreds of repositories. I worked at a company that actually had more repositories than developers. Yeah. Suddenly you're just updating all of these repositories and trying to keep them maintained. So be cautious about just a reason to put something in a box. A much better reason to think about distributed GraphQL is actually organizational boundaries. And with that, we mean teams. Like you have maybe, like Netflix, 130 teams, or you have 20 teams, or 5 teams, and you want them to build independently of each other. Language choice is also not a good reason, because how many languages do you want to have in your company? Maybe 2, maybe 3, but not 130. Technology constraints can be a reason, and scale can also be a reason. Let's talk about scale. So when we talk about scale, it's really 3 things that we should think about. It's scaling data, scaling throughput, so pressure, and scaling developers. So when we talk about scaling data, we often talk about regional data. We call that partitioning or sharding. Sharding really is a method to distribute data across multiple regions, machines, disks, or files. And when we talk about that, it's like we want to put the data close to our customer. So when a request comes in, we want to direct it to the most optimal spot to fetch it from. When we talk about throughput scaling, then we talk about a ton of requests. And we want to scale our instances. And that's where really scaling a monolith, like a huge GraphQL graph, might also be a problem. But this unified API worked for Facebook at a huge scale. So this is not the only reason why you should think about distributed GraphQL. Really, the setup that Facebook did is put a thin layer of GraphQL over the business layer. They called it the ends layer, the entities layer. And they allowed basically users to project what they needed. So when we talk about GraphQL in the open source space, after Facebook open sourced it in 2016, people would build it not like Facebook did, but more in a way that they used GraphQL really as a gateway. They would, and mostly front-end developers actually try to do it because they really wanted to use GraphQL. They would take a GraphQL server and span it over your existing infrastructure. And that gave them a lot of benefits because they could model these entities that they actually have in these services and connect them and give these connections actual meaning. And while they still had this crappy infrastructure behind GraphQL, the front-end engineers no longer had to deal with that. They had these nice graphs. And that also solved a lot of these scaling concerns, because when I did a request, for instance, for my mobile application and just asked for the name of a cryptocurrency or whatever, or a product, then I would just use the service that delivers these data, like the product service. And when my desktop application asked for the same list but needed more information, it would use more services behind that. So when we had like high pressure on our GraphQL layer, which was just very thin on top, we could scale like the services behind that. So we used GraphQL as a gateway. But still, using GraphQL as a gateway has a lot of concerns to it, because we basically have a BFF, just more dynamic, in front of our old infrastructure. And that means we have all the freedoms to put our microservices behind that, and the front-end engineer has all the benefits of this unified API, but we still have all the concerns of the BFF, like high maintenance. We also cannot optimize very well because these resolvers are hard-coded, and there's a very tight coupling between my infrastructure and my GraphQL layer. Let me just show you how people used to do that. We did that also here. We don't only have here these entity framework resolvers. We also used here REST services. Like in this asset price node here, we, for instance, have here the asset price change data loader, which let me quickly go here, where we fetch some downstream. This is an ugly method just to fetch some data from a REST service. You would see something like this, very hand optimized, and this really doesn't scale. Okay. The main concern that really brought in distributed GraphQL then was scaling developers, or scaling our project with developers. And this is really where we talk about distributed GraphQL. It's not only scale, we can scale much better with distributed GraphQL, but it's really scaling with developers. And in such a setup, instead of having these REST services or gRPC services behind our GraphQL gateway, we would swap them out with GraphQL servers. So we would compose our gateway from subgraphs. Each of these GraphQL servers really represent a subgraph that make up this GraphQL gateway. And behind that, we might have microservices. And that's really ideal. Like, you don't have to have microservice. Could also be some other shape or form that you prefer, or even that your subgraphs call your business layer directly. But the idea behind that is that teams can own now a certain piece of your graph and independently deploy it, and they don't have a shared configuration. When they deploy, the overall graph updates and integrates this subgraph. And that's where Hot Chocolate introduces a concept called GraphQL Fusion, which gives you all the capabilities of distributed GraphQL. The idea is here to have basically zero configuration. When you put configuration there, it's decentralized, it's declarative, and composition of these graphs is done at build time to give you an early error if something is wrong. Like maybe you build something in your subgraph that cannot be composed, then you don't want to first deploy it and then fail there. It uses query plans to optimize these requests and use overlapping data, like finding the best spot to fetch the data from. And it also uses throughput to scale that by just using the subgraphs that are really needed for a GraphQL query. Subgraphs are valid on their own, like you could compose them with multiple overall graphs. But there's also transformation capabilities that you have in older technologies of the GraphQL distributed approaches like schema stitching. You have the federation concept and the stitching concepts. On top of that, the GraphQL Fusion gateway has hot reload capabilities. So in short, Fusion is a more natural approach towards distributed GraphQL. But let's have a look at that, because so far we just looked at simple GraphQL servers. Okay, let's quickly get demo 4 up. Awesome. Okay, this is a simple GraphQL setup. I so far just have here subgraphs. I have 2 subgraphs in this demo. One is called accounts, and this account subgraph deals only with users. So I have here a query, and you can see I have here a user, and if I go into that user, this user has ID, name, birth date, and username. And this query here uses entity framework, or in this case I have here a data loader, which then uses entity framework behind that, but it could be whatever you want it to be. And in this instance, we have like here 3 resolvers, like get users by ID, get user by username, and then we have a get users just to get a list, a paginated list, and step through that data. So the second subgraph that I have here is for reviews. So basically reviews somebody wrote around a product for my overall graph that I want to have here. So the graph is around a product catalog where I can write reviews, and I have users basically that write these reviews. If I look at the reviews graph here, I can see that the reviews graph actually has a product, but this product only has an ID. And we have just here a partial thing that is just the reviews. I also can see that it has a user, but this user actually has only an ID and a name and knows the reviews that this user wrote. It's basically the author of the reviews. It also has a review object, which has a body and stars and all these things that are specific to reviews. What we see here really is that we have kind of some overlap between those 2 services. We call that overlapping data, and the GraphQL Fusion engine can use this overlapping data to optimize your request, but we will see that. So what I want to do is now really create a gateway that gives me one view, one overall graph from these services. So what do I have to do for that? Let me just close this. And let's do that. So I'm going here, and I'm using a project template, which is called GraphQL Gateway. This template comes actually with our templates that we have for Hot Chocolate. To install them, I can just do .NET new install, and then it's the Hot Chocolate templates. And I could install them, and then it downloads them from NuGet. I have them already installed. So I can just say .NET new GraphQL Gateway. And then this thing creates me a gateway. If I look at the gateway code here, let's do that. Let's actually refresh that. .NET restore. Then I can see that I basically have almost no code here. It's a single code file. I have here my Fusion Gateway setup, which at the moment is configured to load the gateway configuration from a file, and it's also set up to use hot reload. It could also store the configuration actually in Redis, in a database, or wherever you want that. Apart from that, I have here the HTTP client factory, which is set up to just do HTTP requests. You could configure that with Poly to make it more resilient. And you could also have like header propagation if we had a proper authorization setup here. But apart from that, it's a simple GraphQL server. I can start that. And at this point, actually, this graph has no configuration. So if I call that, it would actually say there's nothing. So now I want to compose my subgraphs into it. And I said that is done at build time. So I can come up here with the second tab. And then I can use the Fusion command line, and I installed that already here. So the Fusion command line is a local tool. It's Hot Chocolate Fusion command line. Go away. And with that, I can compose like the graph configuration. So what I'm doing here now is saying .NET Fusion. Then you can see here, compose my gateway with the review subgraph. Or let's start with the account subgraph, actually. I'm going to do that. The gateway is running, by the way. We don't have to restart it. It is now configured. And we can go here to Banana Cake Pop. I'm actually going here to my gateway configuration. Let's take that actually away. Refresh that. And now I can see here I have a lot of types. And this are actually the types. You saw the methods in the user subgraph. This is a one-to-one translation of my user subgraph. The user subgraph actually is not running behind that. So if I would call one of these, it would fail in this instance. But it's already composed. So I can compose it really at build time and get also build time errors if something is wrong. So let's compose into it the second subgraph and see what happens. So I'm taking the second subgraph here, which is reviews. And then I'm going back here. I didn't restart, but suddenly I have a ton more things here. I have the reviews, but I not only have the review types really integrated with the user types. So I have suddenly here review nodes, I have here an author, which is a user, and I have merged these entities that really belong together. So now I have an integrated graph that I can query. So how this composition really works is that we take these types and we're gonna merge them. And we're gonna annotate which types are really, which data is really where. So we know that, for instance, these two properties are available in both subgraphs, so I can query them for both. I know that these information are only available on the accounts subgraph, and that these information are only available on the review subgraph. And how the composition really works is that we take these subgraphs, merge them into one Fusion graph configuration. So how that is set up actually in the wild would be that you have a build pipeline, and this build pipeline would build your subgraph, basically a .NET build, and then extract from that all the information about this schema. Dump the schema, pack it as a subgraph configuration, and then we would start deploying this. Deploying means that we first download the Fusion graph configuration that is currently deployed outside, and in this Fusion graph configuration are really all information that we need to compose the new version of this graph. So we have all the currently deployed subgraph versions in there. And we also have the public schema that is outwardly exposed in there. So what we do in the composition step is take this new subgraph information and merges with the older ones. Once we've done that and this works through, we don't have an error, we can deploy that, and we are done, we have a new graph. The gateway needs only to be deployed once because we can fully configure it with this Fusion configuration. Let's talk about query plans, because so far I just showed you the composition. To show you a bit the query plans, let's start these subgraphs. So I'm going to run. Project, not the gateway. We're going to take a subgraph here, the review subgraph. It's there. And now I take the other subgraph here, which is the account subgraph. We run that. comes up. And we go here to our operations tab. And we can basically query it. So I could go here, reviews, go into the nodes, take the body, and run this query. And you can see the data is coming in. This is the graph at the moment is new, so it takes the first time to initialize. That is with AOT, you don't have that problem. But now you can see it's really fast, even in such a distributed setup, we have really fast interaction. So let's make really a more complex graph. So let's get this graph out, and then let's really have a look at what's happening under the hood. So I'm throwing this example away. And actually, I have here another demo. This is the full subgraph, also with more things to it, like we have here 3 subgraphs, like a product subgraph, account subgraph, and review subgraph. Let's quickly run these. Come on. And this is .NET Run. Gateway. Okay, gateway is coming up. Then we take the account subgraph here. The product subgraph. It's a bit to type. And we gonna run here the review subgraph. Okay. All these graphs come up. Let's go in here and take a different, more complex query. This is query 3. You can see at the moment I don't have the field here. I need to refresh my schema because I brought a third subgraph in. I refreshed it and I see I can now call it. If I run this query, you can see it has some initialization time, but now everything is up. We are fast. And I can actually look at the query plan. So what I did here is provide a header called GraphQL query plan header. It's only working on development, but I suddenly can look into what's happening here. I have here a query plan. And this query plan exposes all the steps that the GraphQL server does to resolve this data. Let's actually look at that in a more structured way. So when I do the certain requests here, then I get a query plan. In this instance, I queried the products. And the GraphQL server actually looked at how it can fetch these data and determined, like the products data, I actually get from the products graph. So the products and the name, I get that from the products graph. I can compose that, and then I expose here internally the ID, because this ID I need. And then I go for each of the products that I fetch here and fetch that from the subgraph. And when you look at that, you can see, okay, that is not performant because we are actually going now for each of the items in my products graph, in my products list, and fetch something from a subgraph, which would kind of be slow. But the cool thing here is that this is transparent. We can hook that up to OpenTelemetry and see these query plans and reason about them. And then the teams can make decisions part on that. One decision in this case is that we need a batch fetching method in our review subgraph to get all the reviews for a product in one go. So let's do that. In order to do that, I can go back to my solution here, stop in this case my review subgraph, go into my review subgraph, and look at the queries. In my queries, I can see I have here a single method called getProductsById, which just allows me to pass in one ID. To make it batch fetchable, I can now introduce a new resolver here. Oh, sorry. Come on. Which allows me to pass in multiple IDs. So this is totally faked. It's not database here. Just for demo purposes, this would be a call to your service layer or your database or whatever. But it allows me now to pass in multiple product IDs into my resolver here. So I introduced this field here. And I can also give my gateway composition a couple of hints here that this field should be used in a certain way. Essentially give my schema more semantics. So I can basically add here little configuration and then tell it that this resolver actually, the IDs passed in here, is semantically the same as the ID that is returned from this product. And then the composition can reason about the structure of the graph and what it means in that graph. So I've done that. And now I just need to pack my subgraph. This is in the build step. How I would do that is basically I do a .NET run. And then I can export, dump the schema. That is the schema of my solution here. And sorry, I have to actually say that it's the project subgraph and then review subgraph. And then I export the schema here. So it dumps this schema file here. And then we can compose our subgraph configuration. Fusion, subgraph. We pack our subgraph configuration here. And now we can compose our new gateway. Compose. No, why? So we compose our gateway. The gateway is, while we are doing that, still running. So it's already hot reloaded. We can just say .NET run project subgraph. Yes, but not this guy here. Okay, this comes up. We do the same request again. Go here. We rerun that. And let me just collapse the data. You can see now our review subgraph here has a query plan where we resolve first, like before, the products. But now we have here a resolver key, by key batch, where we now collect all the IDs of the first request and then batch them in one go to our new method that we produced here, the products by ID. Like structural, now we have 2 requests and it's fully optimized, and I have a very it's very easy to provide these, and I have full control over how it's batched, and I can put in my optimizations there. So you have this control of these query plans in how this performs. You can even optimize them by hand and provide them back to your gateway. So let's talk about real-time GraphQL, because that was for many distributed GraphQL technologies a problem. Let's have a look at how we handle that with Fusion and .NET. So let's go back to the same solution actually here. And what we want to do is we have here a mutation that provides reviews. So what we want to do is introduce a subscription into that. Come on. That gives us a notification every time somebody publishes a review. So that's an easy thing to do. We added here a subscription type in our GraphQL server, and then we basically do the same like we did before. We dump our schema, then we compose or we pack our subgraph, we compose our gateway, Fusion compose, and then we start our GraphQL server again. And what this pack subgraph actually does is inspect our GraphQL server for how transport works with this thing. Are we using GraphQL over SSE? Are we using GraphQL WS? Or are we using the legacy Apollo protocol? And then it comes up and it just works. So we can now go here, go actually to this demo 2, and then we have here our subscription. I can run that, and you can see I'm subscribed now. Actually, let's refresh that. So this is empty. You can see I'm subscribed. And we can open another tab while this is subscribed. And this another tab is called Create Review. And I have this review that I want to create here. I fire that, go back here, and I can see my result is there. So this is GraphQL subscription in a distributed setup. It's just add your subscription to subgraph, compose. We will figure out how to configure the gateway with transport and all, and just make it work. And let me show you one more thing. So just so this is not fake, I'm changing the data here to whatever. I'm running that, and you can see real-time data works. There are other concerns in GraphQL, but let me see, I have 6 more minutes. There are other concerns here, like there are patterns and best practices. They also challenged GraphQL gateways quite a lot. One of the patterns are the relay schema patterns, like the node pattern or the pagination patterns and stuff like that. And this is also really easy to do with GraphQL Fusion. And let me show you that also quickly. Like I'm going back in here, and at the moment my gateway looks a bit like this. I can go here to my schema graph. You can see I have here query, mutation, subscription. When I go to query, I don't have the typical node field I would have if I implemented the relay server specification, basically the GraphQL best practices that all enterprise GraphQLs would implement. And in order to have that, you don't even need to implement that in your subgraphs. What you need to do is actually just tell us about that you want to use such a thing. So we could go back here, say, compose me the gateway and enable nodes. That's the nodes pattern, for instance. And then we start our subgraph here again here. We go to our GraphQL IDE. We refresh that thing, go to the query type, and there is the nodes pattern, which I can now easily use. Let's do that. Do we have a nodes query here? Yeah, that's a nodes query. For instance, for an item in our graph, it actually just looks up the ID and looks what type it is. I can do that here. You can see it's a product type. I again expose here the query plan, and what you can see is that we have here a sequence, and then we have a specific query plan shape for our node resolver. And this has here a couple of branches, like if it's a product, then we fetch it from this graph. It's a reviews, fetch it from this graph. If it's a user, fetch it from this graph. And at the end, we compose the results and give you the thing. And in this case, I also could like get the product here, get the name, maybe go into the reviews. Let's get the list of reviews here. Body, maybe let's also get the author, from the author the birthday, and then rerun that. And then we get the data here. And we are using now 3 subgraphs here, probably. Like you can see here, we are resolving the node from the product server. And then we compose the result down here. And then we fetch other data from another graph. And down here, we then fetch the birth date from the accounts graph. So everything is composed. So no matter what the complexity is, we take it out. And we allow these isolated work of your teams on their part of the graph and just make it work. There's one more thing. I'm a GraphQL TSC, as I said, and the GraphQL Foundation is something hosted by the Linux Foundation. It governs the open source process around GraphQL. And if you're interested in GraphQL, we actually have a conference in San Francisco in September. So if you want to speak, we are looking always for new speakers in the GraphQL realm. If you have something to talk about in GraphQL, or even if you want to watch it, make sure to sign up for it. And with that, if you have questions, shoot, or I look them up. If you added them to Slido, let me quickly look. I have that down here. No? Damn it, I closed the window, but it doesn't matter. Typical. Audience QA. Okay, what's the difference between Fusion and Apollo Federation? Like Apollo Federation is the first approach towards federated schemas. We actually had a different approach before. We created Fusion to solve all the problems that they introduced with Apollo Federation, like things like the node patterns. Apollo is working for 2 years already on that. It has no traction. subscriptions, things like defer and stream, they just work. And they work much faster. Like we have a customer that migrated from Apollo Federation, and they were using 1,200 pods, and they migrated to Fusion, and now they're using 30 pods for the same performance. Like Hot Chocolate is one of the 5 fastest GraphQL server out there, outcompeting Apollo by, I think by a factor of 15 or so. So there's a ton of difference, but from a conceptual standpoint, we are much easier to use. You saw how easy it is to compose these graphs. Like I had only 2 times to annotate something to make it faster. In Apollo, you can also have low annotations, but as soon as you have concepts like requiring data from another subgraph, you have to annotate that. Then we have like directives, which is complex with Apollo, and there's a lot of complexities around that. We took that out. It's not that Apollo is necessarily a bad solution, but we also learned from these concepts. We used stitching before, and this is just another iteration in this bandwagon of distributed GraphQL. And I think it's much easier, as you could see with subscription and these things. Yeah, so that's also one point. Here's the question, will API stitching in Fusion work with GraphQL.NET implementation, or do I need Hot Chocolate? So Hot Chocolate, that's also a major difference to us and Federation. You can use any GraphQL server, and they don't have to implement anything from Fusion. We can do that with any GraphQL server without polluting your GraphQL server with any code. And also we have support for stitching concepts. Like you can not only federate these configurations, but you have also transformation rules. Like if you want flattened data structure, like if you have this ugly SAP GraphQL integration there, right? And they have not the structure you want to have, you can flatten that, rewrite that, and integrate it into Fusion. Do we need endpoint map GraphQL in program? Yes, you need that. So this is standard. We have the same middleware pipeline. That means you have also the same capabilities that you had with Hot Chocolate, but we have a complete new execution engine under there. How do we know the Fusion correctly mapped the IDs for users? What if we have coincidentally the same names and fields and classes and fields? So same classes and fields just means there's an overlap. That is something you have to work with. Like if you have the same types in the subgraph, it's essentially for us the same time. That means we can put it over each other, and that means we can fetch the data from both sides. Like Fusion will always expect that you have overlapping data first. This is something that in Apollo Federation, for instance, they call shareable. You always have to annotate that. With Hot Chocolate Fusion, we just expect that it is overlapping data, and you tell us if you want it otherwise, because that is the most common case you want to have. And also this, like if the type, for instance, if I had a semantic author type in my downstream service for reviews, it could be named authors, and we would still be able to merge it with the user type. And if it had a different ID structure, we could rewrite that and map these things. Are there limited? Are there limitations towards scale? Like this is specifically built for high scale. So, like to give you the capabilities of scale your subgraphs, you have a very thin gateway that is hot reloadable, and it is just there to route requests to your downstream services, and these you can scale independently. Like as I said, we are looking at 3 kinds of scale here, like data rerouting, overlapping data. It's throughput to your subgraphs, and it's also team scaling, like your developer scaling, so that you can work with multiple teams. Okay. Awesome. Thank you. I think I'm a bit over the time.